Welcome to today's Safer Sim webinar. Today we will be listening to a presentation from researchers from the University of Massachusetts-Amherst, and they will be discussing their project, The Analysis of Driver Behavior and Operations at Intersection Auxiliary Through Lanes. If anyone has any questions, please feel free to use the chat window on the right of the Adobe Connect screen. You can just type your question in there. We will have a short question answer session at the end, but feel free to ask your questions whenever. And I will hand the mic over to our colleagues in Massachusetts.
All right, thank you, Jacob, and good afternoon, everybody. So thanks for joining us here, and if others jump on, we'll be happy to answer any questions you have along the way. As Jacob was alluding to, this is an ongoing series of webinars as part of the Safer Sim UTC, and today we're excited to be presenting some of the results related to a project that we had that stretched across both the field, microsimulation, and driving simulation, so a real cross-cutting project. With me here is Francis Tainter, who's going to do the majority of the presenting today, as well as Professor Eleni Christofa. My name's Mike Knodler. We'll introduce us in just a bit. The topic of today's webinar is analysis of driver behavior and operations at intersection auxiliary through lanes. And we'll be sure to go through and explain exactly what intersection auxiliary through lanes are and what some of the surrounding issues and what ultimately led us to complete the research here. So for those of you that may not be familiar with the Safer Sim UTC consortium, it's a partnership between 5 different universities led by the University of Iowa, where Jacob and Kathy and Don are sitting today. I see that they're all online. It also includes researchers at the University of Wisconsin, University of Central Florida, University of Puerto Rico at Mayagüez, and here at UMass-Amherst, so geographically spread out across a number of different regions. And one of the things that led to the creation of this consortium was really the presence of a strong traffic engineering as well as a presence in transportation human factors. And so much of the work that you see come out of the Safer Sim UTC projects is directly related to that intersection between traffic engineering and transportation human factors. And this project is another good example of that. So a little bit of geography. I think most folks are familiar with Massachusetts is located. One thing that regularly comes up whenever we say that we're from Massachusetts is Boston. We are actually a little bit outside of Boston, so if you see Boston there on the eastern part of the state, right out on the water, Amherst is about an hour and a half to 2 hours west of that. We're located out on the western part of the state, and as I often like to do, it is an open invite. So the campus is beautiful, especially in the late spring and early fall. And you are welcome to come visit us and join us. We'd love to show you the work that we're doing, to show you our resources and have you visit and talk about that. So I mentioned it's Francis, Eleni, and myself. Sometimes it's always good to have a picture that goes along with the voice that you hear. If at the very least you can throw darts at these pictures later if you'd like, but we're excited to be presenting today. Francis will talk a little bit about the Arbella Insurance Human Performance Lab, but that's where our full-scale driving simulator is. We actually have 4 different driving simulators and a couple different virtual reality setups, which are at the heart of our research capabilities, as well as a number of different microsimulation platforms. And we also have a unique set of data in the form of our traffic safety data warehouse. It includes all of the crash data for the Commonwealth of Massachusetts, citation data, commercial vehicle data, hospital data, and all of the normalizing data that goes along with it. And it's really allowed us to increase our footprint in terms of safety, in that we can analyze scenarios, identify what crash patterns exist, and then use that crash analyses to develop countermeasure solutions and wider spread research investigations. So the plan for today, Francis is quickly going to introduce the topic, go through the various methodologies, spend the bulk of the time talking about the research, and then introducing the conclusions and some discussion, as well as some of the work that this current work we're talking about today has led to, and some of the things that we hope to do as we move forward. And with that, I'd love to turn it over to Francis Tainter to go through the bulk of the presentation today.
Good afternoon, everybody. Like Mike said, I'm Francis. I'm a master's student out here at UMass. And today we're going to be talking about auxiliary through lanes. And feel free at any time, like Mike said, to pop a question down at the bottom right corner. There's a few built-in breakpoints that we have, I think, along the way, so we might be able to address them at that time. If not, we'll hold them on at the end of the presentation. So the first question we want to ask is, what are auxiliary through lanes? So a brief description would be additional through lanes that are introduced upstream and drop downstream of the intersection. So you can see from this graphic here, this depicts a pretty basic auxiliary through lane design at an intersection. And actually, I'll walk you through here. So upstream of the intersection, you have the one continuous through lane, and then followed by a tapered section that expands into 2 lanes. Therefore, at the intersection, you have that continuous through lane in the middle and the auxiliary through lane, which is on the right of that picture in the middle there. Downstream of the intersection, the second lane begins to taper back, and you end with the same thing you started with, which is the one continuous through lane. And these are utilized to maximize capacity in a cost-effective manner, meaning designers really want to put these in place to lower cost of projects, as well as still allowing as many vehicles to pass through the intersection during green phases. And it's a lot cheaper than, obviously, 2 continuous through lanes, both upstream and downstream, for the entire roadway. So what Mike had mentioned, we're out here in Western Mass, and more specifically in Amherst. UMass is located up here in North Amherst. We're pretty much a city in itself. Amherst is located, Amherst Center is down here, and then connected to Amherst Center is actually what is Route 9, which leads to the study site that we used for this project. It's the location that really kind of set off the idea of this project. So this is the location down here, and I'll zoom in a little bit further. So this intersection was actually put in following the placement of a Lowe's home improvement store. So once they put the Lowe's home improvement store, they actually made this a signalized intersection. They redesigned the whole roadway to fit that. And so this is the auxiliary through lane. You'll see that this actually mimics the picture I just showed recently with the different parts with taper, upstream ATL, intersection downstream, and then the taper back to the single lane. So this is a perfect intersection for us to do a field study in, and this is kind of the main intersection that we focused on and utilized for this project. So getting into a little bit of background, so there was an NCHRP report that was done about six or 7 years ago that kind of focus more on the guidelines of designing ATLs. And when I say ATLs, I mean auxiliary through lanes. I might be using that abbreviation or acronym rather frequently, so in case anybody doesn't know. And what this NCRP report really did was there was no national guidance on design. A lot of agencies throughout the country came up with their own sort of guidelines for designing auxiliary through lane lengths, upstream and downstream of intersections. And this report really went into the details of studying auxiliary through lanes and determining the safety impacts that these auxiliary through lanes have, both upstream and downstream of the intersection, and the types of crashes that these auxiliary through lanes may either increase or decrease. So in terms of downstream merging scenarios, there may be fewer rear end and congestion related crashes. However, sideswipe and angle crashes may potentially increase. So that's what this report really went into. However, they didn't really focus on any driver behavior aspects because they utilize microsimulation and field study. And so with our project, we wanted to focus more on the driving simulator aspect and really learning what the driver behavior, how the driver behavior is altered upstream and downstream of auxiliary through lanes. So this is basically the outline of what we wanted to find out in this project. So A need exists to evaluate the safety and traffic operations at intersections with auxiliary through lanes, and this really highlights what we wanted to do here. Not only investigating traffic operations, but also taking into account the safety impact that occurs from these auxiliary through lanes. So, in addition, looking into the lane utilization, unbalancing of lane utilization upstream of the intersection, and how that leads to a reduction in capacity. Oh, there we go. Safety-related impacts, as I mentioned earlier. And as a whole, we wanted to use field data, microsimulation analyses, and driving simulation data to hopefully better improve these guidelines for auxiliary through lanes. So leading into our research approach here, like I had mentioned previously, we were going to do a field study here at that intersection I mentioned earlier, followed by a microsimulation analysis in synchro, and then finally culminating with a driving simulator study in the Arbella Insurance Human Performance Lab that Mike had mentioned previously. I'll get into that a little bit further on. So the field study that we completed, we went out to the field. These are just a couple of screenshots of the intersection out on Route 9 in Amherst, Mass. It's actually in Hadley, Mass, just down the road. And we collected some key period data. Not only do we want to collect just intersection volume data, but we wanted to determine the lane utilization data. So we took into account each continuous through lane and auxiliary through lane in each direction so that we could quantify the lane balance between the two. So how many vehicles were utilizing the continuous through lane versus how many were utilizing the auxiliary through lane. In addition to that, we wanted to look into the queue backup. So during the red phase of the opposing roadway, we wanted to determine how far the queue backed up in the continuous through lane and whether there was, a break point where vehicles decided to shift over and utilize the auxiliary through lane once the queue backup reached a certain point. So these are things that we noted while we were out in the field collecting data. And from that, we took some measurements from just some Google Earth images to really develop a geometric design of the intersection. We took the signal timings that we received from Mass DOT, and we calibrated a synchro model to validate these field results that we collected. And that microsimulation analysis actually shown in here. I'll show this quick video for you all. This is really interesting because this mirrors exactly what we see out in the field. And you'll notice that the queue does back up in the continuous through lane and shows a very unbalanced lane utilization for continuous through lane versus auxiliary through lane. And you'll notice that not always does the continuous through lane doesn't always back up completely. There's sometimes vehicles do shift over and utilize the auxiliary through lane, but for the most part, you'll see that again during this phase here. You'll see mostly all vehicles queued in the continuous through lane. One or two may queue up, and you'll see vehicles queue jump and go ahead of the continuous through lane vehicles. So this is an interesting part of this project that we actually I want to show you this last one too, because this is kind of, if you look at the westbound approach, you'll see the vehicles actually create a balanced queue, which does happen, but obviously very infrequently, which is why we want to look into these further. So I had mentioned earlier the Arbella Insurance Human Performance Lab. This is our full immersion driving simulator that we have here at UMass, and this is the driving simulator that many of you have probably seen or in previous webinars we've discussed previously. So this is the old Saturn sedan that we have here, soon to be upgraded, but we have the 135-degree view that we have in front of the car, and the driver immerses themselves in the vehicle as if they were driving on the roadway. And so basically what we wanted to do was take our field and microsimulation studies and input them or replicate them in a controlled driving simulator environment to further test the behavior that we witnessed in the field. So in doing so, we used a method that is relatively new here at UMass, and thanks to all the people at Wisconsin for all of the help they had in this methodology here. But we developed a civil 3D model of our design intersection. We brought that into what is called Blender, which is pretty much a mesh modeling program where we're able to texturize all the different elements of the intersection. And then as a result, we bring this into Internet Scene Assembler, which is where we kind of make the world come to life. And we're able to add all the other exterior roadway elements around the intersection itself, as well as script all the vehicles and signal timings to make the scenario really come to life. And this is what it looks like in real time. So this was one of the drives that one of the eye tracking drives. So the eye tracker is actually a device that we placed on each of the participants, each of the 32 participants that we ran. And what this eye capture does is that it tells us exactly where the driver is looking at every moment throughout their drive. So you'll see that bullseye there, or that crosshair, that is where the drivers are looking at all times. And I actually I'll go back one and show that again. And so you'll notice this is actually a drive where the driver utilizes an auxiliary through lane with the vehicles all queued up in the left lane. And you'll notice that they nearly always focus on those vehicles on the left. And this downstream merge scenario does create some hectic, chaotic driver behavior, which is something that we focused on, and I'll get to that a little bit later in the presentation, but it's just interesting to note some of this behavior that was captured throughout our experiment. So throughout the driving simulator experiment, like I said, we wanted to focus on things that we witnessed in the field. And so these are the variables, the independent variables that we focus primarily on. The first being driver familiarity. So whether a driver was familiar or unfamiliar with what an auxiliary through lane really is. And I'll touch on that in a couple seconds here on the next slide. The second variable is the auxiliary through lane length. So whether the upstream lane was long versus short, and likewise downstream, whether the downstream lane was long or short. And the third variable is queue length. And the queue length, as you saw in that previous video, it's whether there was a queue present in the auxiliary through lane versus a zero vehicle queue in the auxiliary through lane. And going a little bit further, here is the full experimental design of this project. So you'll see that we developed 8 scenarios to test these 3 variables. And it's important to note that the unfamiliar and familiar concepts that are displayed there on the left of the table, those were strictly, so basically we developed 4 scenarios where the driver was unfamiliar with an auxiliary through lane. And then what I would do is I would step in, I would show them a quick picture of an auxiliary through lane, give them a brief introduction of why auxiliary through lanes are designed, without giving away obviously too much information. And then I would test them on those same 4 scenarios and see if their behavior changed and whether they utilize the auxiliary through lane. So we can look at that further. We can look at that further after the first four scenarios. So we have all right, I'll take a quick break. We can take a quick break here. So Cole asked, why does the familiarity with an ATL matter? At first, we actually didn't even necessarily think that it would, because some of the drivers that we had actually were familiar with the intersection that we were trying to replicate. And I think that the familiarity concept creates sort of a comfortability factor where the driver is more comfortable to utilize the auxiliary through lane if they understand what is happening downstream of the intersection. So if the driver understands the concept of auxiliary through lane and understands that the lane will then merge downstream, this could either A, force them or allow them to use the auxiliary through lane, or B, to be kind of patient and stay in their continuous through lane, knowing that downstream they're going to have to merge right back anyway. So I think it's an important aspect to look into.
And there's another dimension that we were looking at as well, in that many of the drivers, many of the behaviors that were being observed out on Route 9 were a function of drivers knowing that the lane was added and then quickly dropped downstream. And so one of the things that we had hypothesized is that they didn't want to switch lanes just for the sake of having to merge right back in just on the other side of the intersection. So they knew that happened, so they weren't going to make use of that auxiliary through lane unless it was the only way by which they could potentially get through the signal. So certainly, we wanted to gauge their familiarity based upon that fact. But also as part of this was the familiarity is twofold. It's were they familiar with the fact that the lane's going to disappear downstream, but also familiarity with the idea of how auxiliary through lanes are intended to work. And I think that's what is important there. So we'll get to this one.
Yeah, I see your question, John. I think I might hold off because I might touch on that a little bit down the road, I think I'll get to that. So I think hopefully your answer should be answered in the next few slides here. So going from the experimental design on the last slide, this is just one of the sample modules of our participants. So in order to counterbalance any bias of scenario display, we utilize a Latin square in order to control where the scenarios were displayed to each participant. So this is just simply one module. So for participant A, B, C, D, what that really means is participant 1, 2, 3, and 4. And what we did was replicate this module 8 times to result in our 32 total participants. And you'll see that there's a randomized order of scenario, a randomized scenario order for each participant. And again, you'll notice that for the first 4 scenarios and the second 4 scenarios, those are the same order. So each participant viewed the first 4 scenarios in the same order as the second 4 scenarios. And the reason for that was to fully focus on the familiarity concept that we discussed earlier.
Introduced right there.
Yeah. So now we're getting into a little bit of the results, research results here. So from the field study and microsimulation analysis, here are just some of the volume data that we captured out in the field. And you'll notice that in each of these tables, you'll see that FLU aux, so the lane utilization factor that we determined from each approach of the intersection during each site visit. And you'll notice that in the eastbound direction for both site visits, it was around 23% utilization for the auxiliary through lane. And that means that only 22% of the vehicles, the through vehicles, are utilizing the auxiliary through lane. In the westbound direction, there is much less. It's only around 10% utilizing the auxiliary through lane, and this is much lower than what the literature states that auxiliary through lane should be utilized. So 10% is very, very quite low in this sense for that. Comparing the field data to the synchro output, so this is the Q data that we received out in the field. We had an average Qs displayed here from the field and compare that to our synchro output. And again, this was all collected out in the field like I had mentioned earlier. So determining maximum Qs. And these were actually utilized in determining what I had mentioned earlier as a Q breakpoint. And we really utilized these Q breakpoints to develop our driving simulator scenario. And so in terms of deciding how many vehicles to script into the simulator to fully understand how the Q affects the driver behavior. Looking into the driving so this is the results from the driving simulator study. These are the green there represents continuous through lane utilization, and the blue represents auxiliary through lane utilization. And each one represents each scenario. So you'll notice in the first 4 scenarios there, the green prevails, so that most vehicles are utilizing the continuous through lane and underutilizing the auxiliary through lane. But you'll notice that once the driver became familiar with the auxiliary through lane, the blue starts to prevail, and the more drivers utilize that auxiliary through lane as well. And you'll notice 5 and 7, scenario 5 and 7, if it might be hard to remember back to the design, but scenario 5 and 7 were actually the 2 scenarios where there were zero vehicles queued in the auxiliary through lane, So clearly drivers were more likely to move over, shift over, and utilize that. Yeah, so clearly more vehicles were likely to move over and utilize the auxiliary through lane when there were zero vehicles present in that lane to begin with. And then going through some statistical analyses that we completed here, looking at the first one, queue versus no queue. So like I just said, the queue, whether there was a queue present in the auxiliary through lane versus no queue. And you'll see, like I just mentioned previously, in scenario 5, 6, 7, 8, there was significant differences between a queue versus no queue. So the queue had a significant impact once the driver was familiar with the concept of an auxiliary through lane. In terms of familiarity, this prevailed to be our strongest significant output. So comparing scenarios 1 and 5, so those two are just comparing straight familiarity utilization. So whether the vehicle had any, whether the familiarity of the driver had any impact on the lane utilization. And as a result, the total familiarity versus unfamiliarity scenarios did yield a statistically significant result in that manner. And for the last variable here, the long-short versus short-long lane length, this did not necessarily yield any significance in this study, and there's definitely some hypotheses that we have for why that is so, and I'll just jump right in here to the last slide. And so lane length definitely, it did not yield any strong significance in our study. However, it's definitely something that, and that kind of does contradict some of the literature that we've read previously. So that was definitely one of the most shocking results that we had here. But I think what we were talking about earlier with queue length, queue effect, you'll even see it in this graphic here on the bottom where you have 5 or 6 vehicles queued in the left lane and only 2 vehicles queued in the right lane. Clearly that has an impact on driver behavior as they approach the intersection. So drivers are much more willing to utilize the auxiliary through lane when there are fewer vehicles already queued in there compared to the continuous through lane. And as I said previously, the familiarity concept in lane utilization, this yielded the strongest significance, and this is something that we could even branch further off of and talk about, where once the drivers are familiar with the design concept and the design narrative for auxiliary through lanes, they understand more so why those lanes are there and why designers put those lanes in place for intersections. So that obviously those lanes that are there for a reason, to increase capacity for an intersection. And once drivers understand that, they are much more willing to utilize those lanes. And then lastly, what we determined from this, as I had mentioned previously in one of the videos, was that the downstream merge behavior sometimes became erratic for drivers trying to merge. So downstream of the intersection, it became difficult for drivers to merge, and those are some of the things that we noted while we were concluding this study. And actually, we completed a post-study questionnaire which asked drivers about the downstream merge concept. Not only do we ask them about their thoughts of auxiliary through lanes in general, but we actually wanted to see what their thoughts were on the potential for an alternative merge sign. And you'll see from this picture here on the left, so this is actually from a study that was done in Connecticut 10 or so years ago. And what the study looked into was the safety impacts downstream of merging. And what they wanted to do was try to create a more balanced merge, a more alternative merge is what they called it, downstream of the intersection, so that drivers were more likely to yield to each other rather than one lane yielding to the next. And this is just one of the studies that kind of branched off from this auxiliary through lane study, and we actually have recently completed some preliminary results. We have some preliminary results here from that alternative merge study. So this was actually a computer static evaluation that was given to 235 people. And basically what this computer static evaluation did was we wanted to look into the preference for varied alternative merge signs downstream of an intersection. So you'll see on this left graphic here, those are all the different signs that we tested in the static evaluation, and you'll see which ones drivers most preferred versus which ones drivers least preferred in terms of promoting even merging. And you'll see that the standard sign there on the left clearly is understood by drivers that it does not promote even merging, and you'll see actually all the way on the right, opposite of that, the most preferred, whereas a simple alternate merge sign that drivers preferred the most. And this was administered through a simple online survey, and it led into a driving simulator study, which we have recently, it's recently underway. We anticipate on having 24 participants in the study, developing 12 different scenarios to analyze the lane choice of drivers upstream of the intersection ahead of a downstream merge. So some of the variables we were looking into are lane positioning, so whether the vehicle starts in the left lane versus right lane, the traffic configuration in front of or next to the vehicle, and the merge sign displayed, which you can see over on that right picture. So upstream of the intersection, we want to tell the drivers that they will be merging downstream, and then let them know what sign they will see, and we want to see if that sign that we display to them upstream of the intersection has any impact on their lane choice upstream of the intersection in preparation for the downstream merge. And the importance with this additional study, I think, really relates back to auxiliary through lanes, because if we can further determine the downstream merge scenario to make that more balanced, I think that ultimately will lead back to a more balanced upstream lane utilization, which is ultimately what we're trying to do with auxiliary through lanes, and we want to create a more balanced upstream lane utilization to maximize capacity and ultimately make the best design possible for not only auxiliary through lane, but make safety priority number one for the merging scenarios downstream. And with that, I want to thank you for your time, and I'll open up to any questions. I think we have a couple here, potentially. All right, so Cole asked, are you looking at any safety-related measures? Is this for the alternative merge? Yeah. Alternative merge. So in terms of the alternative merge, we're still debating what we want to focus on for the safety-related measures. Downstream of the intersection, I think. Right. I think once we investigate further the vehicle trajectories, I think we'll better understand. We can kind of relate passive versus aggressive drivers and how that affects safety at the merge point downstream. Because some of the things that I've actually noticed while running participants is that there are varied aggressive factors that drivers have downstream of the intersection, and it's finding out how to quantify that we're working on right now, I think. So, John, I'll address yours. So in terms of the existence of a right turn vehicle to Lowe's, that's definitely another variable that could be studied further. I think, obviously, with a right turn vehicle, the user vehicle will be much less likely to utilize it. Obviously, it depends on what type of vehicle. There are other studies that have talked about heavy vehicles, so whether there's a heavy vehicle in the right lane versus left lane. So I think that kind of
and what there is something to what you're suggesting. One of the things that we had observed in the field is that oftentimes once one vehicle went into that right lane and it was clear that they were not turning right, subsequent vehicles were likely to follow them. So that might suggest that there could be something to the fact of nobody wants to be the first one because they don't want to potentially block somebody that may want to turn right off of the main line. So there could be something there, and that certainly would be worth looking at. But you know, nothing concrete at this point. All right, so just one closing thing. I know one of the things that will happen is this will, it'll take a few days to get it all bundled up and edited, but this will ultimately appear online, and you'll all be sent a link so you can share it with folks as possible, or as you'd like to. It'll be on the SaferSim YouTube channel, and Jacob and Kathy will send out that link as it goes. And in the meantime, you've got our contact information there. By all means, feel free to contact us with ideas, thoughts, suggestions, questions, any or all of the above that you may have as we move forward. This is something that, you know, Francis mentioned we're still actively looking into, and you know, it's a classic case of every question that we seem to answer results in the introduction of 3, 4, or more different questions. So it's been really fun to study. Started relatively small with one intersection that seemed to not be working quite the way that we thought it was designed to, and it snowballed a little bit from there. So we're having fun with it, enjoying it, and encourage you to ask us any questions that you might have along the way, again, whether it's today or otherwise. And thank you, Bill, for the nice note. Appreciate that. All right, take care, everybody. Have a nice day.